Kia ora Year 12 and Year 11. This video is going to go through the first Algebra Readiness check sheet. This one is on manipulation. This will be a bit longer than the usual videos because it's got quite a lot of questions, but if you can hang in there and you are the first person to find the 80s song somewhere in the video and you send me an email, I will deliver you a chocolate fish in class in the first week back. Good luck. Right, so number one, expand and simplify. Here we go. Right, so expand and simplify this cubic expression. Right, so the first thing I do is, I usually expand these back two brackets, but it will depend a bit on the combination that we've got. But in this case, expanding the last two is easy because it's an x times an x. So we'll leave that first one sitting there. And we get x squared minus 5x plus 4. So now I'm going to expand by multiplying everything in here by 3x and then everything by the 2. So when I do that, this is what I'm going to get. So 3x cubed minus 15x squared plus 12x, and then when I multiply everything through by 2, plus 2x squared minus 10x plus 8. Right, now that equals 3x cubed minus 13x squared plus 2x plus 8. Now, you don't have to use this method that I've used here of lining things up by column, but it does make it very easy to spot the like terms if you do that. The other thing to watch for in problems like this is to make sure that you bring the sign with the coefficient, so it's minus 15, not plus 15, but we've gone over that lots in class, so that should be fine. Okay, I'm going to insert a new slide here, so there might be a little gap in the video. Right, the second question, 1b, is to expand and simplify 2 minus x cubed. Right, now, be really careful, it is not equal to 2 cubed minus x cubed. Right, definitely don't want to see any of that. With these, just do what we did before, write it out in full. Okay, expand the back two brackets, so 2 minus x times 4 minus 4x plus x squared. Now expand 2 times all of that, and then minus x times all of that. So we will get 8 minus 8x plus 2x squared minus 4x plus 4x squared minus x cubed. And that gives us 8 minus 12x plus 6x squared minus x cubed. Okay, on to the next two, which are factorising questions. Right, 2a, factorise 10h squared minus 7h plus 1. So a very nice, easy one that we can do by sight. The first thing I notice is that I've got a plus here and a minus here. So I must have a minus and a minus. The next thing I notice is I've got plus 1, so it must be minus 1. And now I can see I want two numbers that times to give me 10, right, and add to give me negative 7. So it's going to be 2h and 5h. So have a look at that, see if we're happy. Yep, 10h squared minus 5h minus 2h plus 1. So that's good. Right, next one. Got to be careful with this one. Factorise x to the power of 6 minus x squared. Well, first we take out the common factor of the x squared times x to the power of 4 minus 1. Just put a line through there, separate question. Now here I notice, so hopefully all of you are noticing there's a difference of two squares pattern. So we have x squared times x squared plus 1, x squared minus 1. But we're still not finished because we've got another difference of two squares here. So the full answer is x squared times x squared plus 1, can't factorise that, times x plus 1, x minus 1. Right, note you were given a hint on the sheet, have you factorised fully? in bold. So just make sure you got all the way there on that one. Okay, next two questions are simplification ones. Right, simplify fully. The first one. 2 to the n plus 1 times 2 to the power of 2n over 2 to the power of n minus 2. Right, well I've got the same base, so I just add the powers. Right, n plus 1 plus 2n gives me 3n plus 1 divided by 2 to the power of n minus 2. Right, I've got a quotient and the same base, so I subtract the denominator power from the numerator power, so I get 2 to the power of 3n plus 1 minus n minus 2. So that works out to be 2 to the power of 3n plus 1 minus n plus 2, which is 2 to the power of 2n plus 3. Okay, question 3b, simplify fully. 9a squared on 16 to the power of negative a half. Right, several ways to do this, but typically when you see that negative exponent, we know it means take the reciprocal. So we have 16 over 9a squared to the power of a half, right, which is just getting the square root of the numerator and the square root of the denominator. Question 4, write this in index form. Okay, well, I'll do this in 2 steps. Many of you will do it in 1. So this 3 means I've got x to the power of something over 3, and this 2 means it's x to the power of 2/3. Now, we're asked on the written paper, we want it in the form ax to the b. And even if that wasn't said, if you were asked to write this in index form, you wouldn't want to have it as a fraction. You would be looking to have it as 5x to the power of negative 2/3. On to question 5. Right, log questions, simplify. Log 3 plus 3 log 2 minus log 6. Right, this is using our log rules. The log of AB is equal to the log of A plus the log of B. And the other one, log of A over B, is the log of A minus the log of B. So in this question here, we're working backwards to get the log of a single number. So this equals log of 3 plus the rule that I didn't write up there, which is this is equal to the log of 2 cubed, right? So plus the log of 8 minus the log of 6, which is equal to the log of 3 times 8 over 6, which is the log of 4. Okay, this is the musical interlude. First person to email me gets the chocolate fish. Right, back to logs. Right, 5b. Simplify. 1/3 log 8 minus 2 log 2. Right, so that equals the log of 8 to the power of 1/3 minus 2 log 2. So that's the log of 2. Cube root of 8 is 2 minus 2 times the log of 2. So I collect up my like terms. I've got, really, this is 1 log 2. And this is take away 2 log 2. So I get negative log of 2. Now the other way that I could have got that same answer is to go from the start, log of 2 minus the log of 4, so it's the same first line, which equals the log of 2 over 4, which equals the log of 1/2, which is negative log of 2. Okay, so 2 ways to get to the same thing. Right, next question. Log of 3 over log of 9 equals, well, we have to have a think about this one. So the log of 9 is equal to the log of 3 squared. So we're going to apply our power rule here. We've got 2 log 3 in the denominator. The numerator is 1 log 3, so we can divide top and bottom by log 3 and we're left with just 1/2. Right, 6a, simplify fully. 3x squared minus 12x over x squared minus 8x plus 16 equals 3x into x minus 4 over x minus 4 squared. So that equals 3x over x minus 4 as long as x is not equal to 4. Right, so x can't be equal to 4 because that would give us a denominator of 0, which we don't want. Right, 6b is a simplifying fraction example. So we need to make a common denominator, which will be x plus 1, x minus 1, and we're multiplying top and bottom by x minus 1, which you might call cross-multiplying, and then the same thing for the second part of the fraction. So that equals 2x minus 2 minus 3x minus 3 over, fine to leave the bottom as it is for now, and that equals negative x minus 5 over, well, you could leave it like that, but I think I'd prefer to see it as x squared minus 1. Okay, but you're probably okay also to leave it factorised. Alright, 4 little sub-questions left, 2 on changing the subject of a formula. We'll do those now. Right, the formula for the volume of a cone is V equals 1/3 pi r squared h, and we're asked to make r the subject. Right, so first we get 3v equals pi r squared h. I'm going to run out of space. 3v over pi h equals r squared. So then r is equal to plus or minus the square root of 3v over pi h. Right, now you need to have this, because if we don't, it just means the positive square root. And r squared is going to be a positive number, but r could have been either positive or negative. Next question, make s the subject of this formula. T is equal to the square root of 3g over p plus s. I'm going to start by squaring both sides. T squared equals 3g over p plus s. Now I'm going to cross multiply. So multiplying both sides by p plus s times t squared equals 3g. Now I expand because I'm trying to isolate s. So pt squared plus s t squared equals 3g. S t squared. I'm very sorry for the squished upness here. You know that if you did this in your book I would be deeply unhappy. You can feel free to tell me that in class when you see me. 3g take away p t squared. Lastly we're going to divide through by t squared. So we'll have s equals 3g minus pt squared over t squared. Now that's one way to write it. The nicer way to write it would be s equals 3g over t squared minus p. But I think either of those would be fine. Right, 2 little solving questions to come. Right, the first one, solve log to base x of 125 equals 3. Rewrite it as an exponent equation, x cubed equals 125. Remember, logs go like this. X to the power of 3 equals that. X equals 5. Now there's only one solution there with that equation because x has an odd power. But the other thing to notice is that we can't have the log of a negative number. Right, it's just not defined. So when you're solving log equations, the base must always be a positive. Okay, if you've got questions about that, ask me some more in class. I'll go over it again. And then our very last question on the next slide is, right, log to base 2 of 12 plus log to base 2 of x is equal to 3. So we can rewrite the left-hand side as the log to base 2 of 12x equals 3. And now we're going to get 2 cubed equals 12x. So 8 equals 12x. X is equal to 8 over 12, which is 2/3. Okay, hope that helps, and I hope you found that revision sheet useful. Thanks for watching, and please let me know if there are any technical glitches.